So here I have a much trickier example of motion with calculus. The motion of a very erratic body can be described as v of t is 4 divided by t squared plus 25 meters per second. Initially, the body has a starting position of x equals 1 meter. But to find the displacement of the body after 3 seconds and show the maximum speed of the body is 4/25 meters per second. Now, before you jump into this, I would like to give a couple of hints as to starting this question. There is an integral identity such that if you have dt divided by t squared plus some constant alpha squared, this is 1 over alpha tan inverse of t over alpha. So that's a key thing to understand. Another thing with initially, so these initial conditions, this means that x is 1 when t is 0. So you can put that into your integral. So try this yourself, and when you're ready or if you're stuck, come back to this video. So here is a model solution with part 1 on the left and part 2 on the right. So we know that v is ds by dt, so moving everything over, we have ds equals the integral of our function v of t dt. So once we integrate, we know that t is 0 when s is 1, so that's its initial displacement. And we're told to find after 3 seconds, so our second integral boundary is 3, and our second integral boundary here is s, so it's just a general sort of displacement, because we don't know what it's going to be, so we just denote it as s, so we can simplify it down quicker. Again, here's the identity written. Here, this is just, the integral of ds is just s, and so you are integral boundaries. When doing this, you can factor the 4 out, because it's just a constant, and you get 1 over t squared plus 25. So once you integrate that, using the rule, we have, that's 1/5 tan inverse of t fifths, between the boundaries of 0 and 3. So we can substitute it all in. Tan inverse of 0 is 0, so that was gone, and we just have, adding 1 after it, we get 4/5 tan inverse of 3/5 plus 1, which is about 1.43 meters after 3 seconds. So if you managed to get that, very well done. The second part is to do with maximum speed. Now, the graph of something like this is very complex, but it's essentially finding when the derivative of the velocity function is 0, or when the acceleration is 0. Because once the acceleration is 0, then it's not going to be changing speed. It's either, once it hits acceleration of 0, it's only going to go downwards. In most cases, we're not going to deal with sudden jolts of acceleration, so it's max when v of t is 0. So differentiating, when using the quotient rule, we get minus 8t over t squared plus 25 all squared equals 0. So that can only be true when t is 0. Then when t is 0, we substitute it back into v of t, and we find and prove that the maximum speed is 4/25 meters per second. I should have written a QED there, but that's that question done. And if you got that all 100%, very well done.